Hi, everybody. Some people are still joining. I'm Sébastien Gonzalve. I'm a software engineer. I worked almost 20 years ago for a startup that was making distributed system, in which I stayed about 7 years. Then I was working on audio layers for a big company of semiconductors, and for 5 now, almost now, I'm working for an automotive constructor, and on embedded systems. So I don't have a much more presentation in slides. There's my email address at the end of the talk if you want to email me, and you can search the internet for me. You will find me quite easy, I guess. So let's go. This presentation is about why you should move to your legacy code to smart pointers. So as a preamble, I want to say that this talk is about refactoring. Thus, if you want to have good refactoring, you have to have tests, kind of tests. So anything that would do the task or checking for non-regression. So if you have no tests right now, your priority is probably not to try to refactor anything, nor change, nor listen to what I will say later on changing a smart pointer, well, using smart pointer, but maybe you should focus on adding unit tests in your code. On the other hand, if your code is end of life and it's already like this for more than 2 or 3 years, let's say, and nobody is supposed to change it or is not supposed to be embedded in any new product in the future, I think it's also not a good idea to try refactoring this. Well, it could be interesting for the fun, let's say, but I don't think it's worth the pain if it's expecting some real return over investment. So here is a usual example of code you encounter and you just wonder what's happening there. So you see some class, you see some vector of pointer and integers, no copy constructor, and a destructor that takes care of iterating over each element of this vector and cleaning it. And the question remains, so is that supposed to work correctly? How do we know that it works correctly, especially because there is no copy constructor? And we have some pulsion to transform this code to at least fix it, but is that still a good idea to fix it? But I must say that working at this talk came a question. Actually, we have a smart pointer from C++11. Well, there were auto pointer before, but let's put that apart. They are here for quite a long time now, and the question was in my head, let's say it's more or less 10 years now we have those tools, and it's still difficult to have people adopt this, refactor their code using those smart pointer. And in the end, the first question I was asking is, in fact, why is that so hard to move to smart pointer? Because it should be so normal to use them. So here's a slide you've all been expecting. A modern problem requires a modern solution. So let's focus on what makes people not to change. So I'm not a psychoanalyst, and I did not make psychology studies. This is just the best answer from the internet, but I think it's really the main reason one can encounter while trying to change things and convince their coworkers. So the first is the fear of losing something or getting confused with the code. People are usually considering the code is something they wrote and they finished, and they are quite afraid of why changing that something work. And they have tradition. We always did like this, etc., etc. So here are a list of evidences you may hear when you ask people, and some of these explanations are. We don't know C++11. To the question, do we really lose something? Usually people argue that the code is working right now. And this is usually something really interesting to challenge, because when you talk with them, you learn things. So the first question is, are they unit test or validation tests? So I already talked about this, but when you are really asserting that code is working correctly, can you prove it? Do you have coverage proving that you have tests and those tests are relevant? You can show that you are really testing in depth the code. The second question is, does it always work? Do you experience some crashes, some unintended behavior? This morning I had a talk about synchronization, and I talked about a random result when multi-threading. This may be the case. Maybe you have some code that is randomly crashing or giving the wrong result, and maybe it's because of exceptions. And this must be a clue that something's wrong happening. So maybe it's worth explaining that what we as a team consider as a working code is not really that good, in fact. The last point is, are there tools passed and to check the quality of the code, to check if there are leaks or memory corruption. Because if we don't have those tools passed, maybe it's time to pass them, and maybe passing them will show us as a team or some members, if there are special guys or people in general looking to proof that there's something to fix, that there is something actually to fix, maybe leaks or corruption. Some people will argue that it's more work, and as a matter of fact, changing a former code is for sure adding work that is not planned at first, because usually backlogs in teams, etc., is focused on adding features, and refactoring is sometimes part of the task. But anyway, if you had refactoring to your daily task, you will see that as more work anyway. And you may feel that people feel it like this and don't want this extra work to come, when you can hear them telling, well, okay, but we'll do that next year, or okay, all this is really nice, but maybe it's too late for this product. Maybe we should try to set it on for the next product. We will start it in the near future. Or maybe people will say, okay, this is really great. You have wonderful tools now in the language, but in the end, what's the return of investment for this? Actually, it's great. You are having fun manipulating those things, but it's not really useful. So more work is not always more work. So here is a classic example. You have a class with the collections, the one I shown you before. Transforming this code using smart pointers becomes nothing, no code. And this is a very important thing, because no code means no maintenance, no bug, nothing. So here, the return over investment is really huge, because maintaining those code was maybe a pain or maybe a problem. There may be bugs, I would say, and it becomes nothing. By the way, it could be more efficient also. There's also the fact that people need to be convinced that the benefits will come fast. Telling people you will have less bug, you will. It will be easier to work, to do stuff in the existing code is nice, but what they want is to have less work now. They want to have the benefits now. So we have to prove people when we want to push such changes that benefit will come fast. And usually it comes through the upcoming evolution of the product or of the code. Usually the code was difficult to set up. I'll just show everything. It was difficult to set up. It was difficult to test. It was difficult to debug it. And finally, it was not that simple to have it work as people may remind. And just saying that if we think that future evolution of the code will pass through the same pain, the same bugs, the same difficulties to have the full code being stabilized, maybe we can have a clue to help people move in the right direction and say, okay, yeah, maybe we should find some better way to do it, because it was such a pain to have it work that now I would move to something that will actually help me. The last point here is more work, yes, but when you enforce correct use of APIs, what is possible thanks to smart pointers, then using those APIs is easier also. So using them is less error prone, etc., etc. So it's more simple to have the whole stuff working correctly. The last point was the fear of failure. People need to feel they will be able to be successful. You may find some evidence of this kind of fear when people are getting crazy because they gave a lot of error while compiling. They don't say, yes, okay, it may be tricky to get through these errors. They just complain and just ignore those errors. Say, this is giving me true work. I don't want to do that because this you see the compiler gives me too many errors. It's just not possible to do this task. Other reason are the size of the code. People imagine that they will need to put the smart pointer everywhere in a single pass, and it's just impossible. So they see the task as much too large for the time slice they have. And some would even say they don't like C++ even at all, at least it's said. So how to work on this? Mainly by getting help. Usually training team is something needed prior to start. Mainly people are afraid of change because they feel they won't be able to be successful, because they feel like they won't be able to learn those things. So some training may be useful to help them get confident on their capabilities, and also show them that it's not rocket science. It's just using new APIs or new structure objects from standard libraries. By the way, they may also use different compilers to get different errors, so that they can get relaxed about ugly errors they may get with some compilers. And obviously, fetching the internet, there are a lot of resources about how modern C++ work. I think it's possible. So I think we, as persons that want to push those effort of modernizing the code, should take care of having all our coworkers getting trained on those new things and being able to use them on an everyday basis, and not saying, okay, it's modern, we should use it, and let's go on. Here is a quick summary of when to pass pointer, a smart pointer as a function parameter. So it would may be part of some kind of training. Here is just a summary. You may find all this in the CPP core guidelines. Here, I just want to insist on the fact that the main point is about ownership around about this object and the way you use it. The first thing you can find in the CPP core guidelines is trying not to use smart pointers as a parameter of your function if they are not useful then. So maybe you can just pass references or pointers if you need to nullify something at some point. And anyway, passing a row pointer as a kind of as a semantic of no knowing. When I pass a row pointer to a function, it would mean that this pointer is not owned, so it's just a temporary buffer you can work on or temporary object, but you don't have to keep it somewhere. So the extension of this would be that if you need to pass a smart pointer in your function, it means that you transfer the ownership when it's a unique pointer, or you want to share the ownership with the shared pattern. The last way of passing this is using references. So passing references of a smart pointer, usually, let's say, one should take care when doing that, because the only use case I would say that is useful is when you need to reset things more or less, especially when on unique pointer. There are no real reason of passing reference on unique pointer other than just being able to reset the pointer itself. For shared pointer, it's more or less the same. It may be const, but that's the detail. So here, I give you the link to the CPP core guideline. If you don't know them, just read them. It's really, really interesting. There are a lot of examples there. And it's a good basis to learn how to do that, I would say. So you can be the ones that bear the change in your company or with your coworkers. So that was the first part of this talk, trying to say we are all on the same boat, I would say, and we need to help each other to move toward this. And eventually, if we want people to use those smart pointers, we have to help them to figure out it's needed. So the next part is more about techniques or example on how to do that to help people move their code to that. Some usual patterns. So here is a class with a map. So it's used in main. So here it's a bit clumsy, but it's just an example. I create a class S1, an object S1 and an object S2. And as you can see, I just copy S2 in S1. And okay, it's working great. But someone one day adds a field in this class, and obviously it does it like this. It's a buffer, it's allocating bytes, and then it's deleting it. So maybe you already noticed that there is an issue here, because the person that did that made an error. It uses malloc for allocation and delete for the buffer. So there's already something wrong here. This is not legal, let's say. And then in the main, he also added something like this. I would say he goes through the buffer. But the problem here is as there is no copy constructor in this class, both instances S1 and S2 are sharing the same buffer here, which means that when here we'll go out of this scope, this buffer is deleted, and here we are just going in indefined behavior because we are working in a space of memories that was deleted. So this is a really classic example, and I saw quite a lot of code, even working for long date, having those kind of problem. And what's going when movies to smart pointer? So it's more or less the same. My map, I just put a unique pointer for an array here. So here there is no problem with destruction, because make unique will and the unique pointer will take charge to make sure new and delete are called correctly. So it's a correct delete that is called as well. And if I try to compile a former main, I won't be able to compile it. Here I will get such an error. So it's complaining that here this line won't be feasible from the compiler point of view, because the operator equal was not defined, and it cannot create one for me, because as I'm having a unique pointer in my class, my class becomes non-copyable. It's implicitly deleted. So we moved from something that is undefined behavior and needs reviews, etc., to something that doesn't even compile. So this is really interesting, especially to prove that it can save a lot of time. This move will fix bugs and make the code more robust with less code. Here is another example. So it's an example to illustrate the use of shared pointers with weak pointers. So I'm not about to explain in depth weak pointer again, shared pointer. Usually the classical example given for weak PTRs and shared pointers are cyclic dependencies, but one can see it in a quite different way. Actually, a weak pointer could help you to know if the shared pointer that issued it is still valid or not. I would say if the object that we are looking for is still there or not. So it's a way to, let's say, observe that this is still alive or not. So here is an example of quite simple code using an observer pattern. So I just create a class that registers a callback to an observee here. So the function register callback just register a callback, and later when I call call on this observee, the callback to the observer is call, and things are doing like this. The point here is I have some kind of strange construct as well. I create my observee here in main. So okay, so I create the class that wants to observe here in a sub scope. I do something with my class. So this makes me register my callback, which is the lambda that captures this through this, and I call the call function of the observer. So this is working correctly at this place because everybody is here. The problem is when I get out of scope, my observee keeps having a function that is pointing to nowhere, and this is just a bug. The class was destroyed. So you may fix, it's just a suggestion, this by using some weak pointer and use some shared pointer to create a cookie. So the class would embed some kind of cookies that is just a shared pointer to any. So I just put anything here. And then you capture a weak pointer in your lambda, and in the lambda you can make sure that my class here is still here or not. If the cookie exists, which means if the shared pointer here can be still present, then my class exists still. Otherwise, it was destroyed. So what I get here is this call is okay, it's displaying hello, and this one is still okay, but it's displaying callback discard. So you may see that on live things. So I should speed up a bit, but this is very useful also for wrapping C APIs. So usually people end up using C APIs for many reasons. Maybe it's MySQL, maybe it's OpenSSL, maybe it's FFmpeg, and these are C APIs, and it makes Rai quite difficult at first sight. But with a smart pointer, you may use that. So here is an example with FFmpeg, which allocate a frame with alloc and needs. You see here the link to free them via frame free. So this would be the correct code. We need to add a free at each if in the code. This may be painful if you already did it. So what can we do is using a unique pointer specifying the deleter here. So you can write something like this, and then there is no more leak because it's automatically freed. And when you use it in the legacy function, you just do get to get the raw pointer, but that's okay because this function does nothing with allocating or desallocating of the pointer. So this is maybe quite ugly to write. So you may be able to write something like this, but the problem is with FFmpeg if it's not working because the deleter is actually taking a star here. So what you can do is pass a lambda, but it remains quite clumsy. So people don't really like this in general. So what you can do is create a frame deleter object that you will use in the type of your unique pointer, pass here as a functor, so that when writing in your code, you just use the type def you create here and create a frame that allocates things via the the FFmpeg API, but remains a unique pointer which will be deleted and all the stuff. So the code become really simple, as you may see here. I use my unique frame, and then it's okay. So this is really powerful, and this is really helping covering a lot of bugs when using such C APIs. Here is just a little slide to stress that you should use shared pointers wisely. Resist the temptation to put shared pointers everywhere, just saying, okay, I don't just want to bother with thinking to what is owning what. So let's just put smart pointer everywhere, and in the end, it will just go away in some way. So let's say the Java approach. What's really interesting in the fact of refactoring and using smart pointers is that it forces us to think about the design, and each time we pass a pointer to someone, is that the correct semantic we want? Do I want to express passing ownership to this function or not? Is it just using the object, or is it taking the ownership, or do I need to share the ownership? So really, if you try to think about this, you will have better code than just putting it everywhere. So I'll try to finish on advices. If you do such kind of rework, you may start by upper layer and go down your hierarchy, because usually it's easier to wrap upper layers and get raw pointers from your smart pointer and keep passing it down the hierarchy than making the lower layer taking smart pointer and thus having to change the call site of all your function. Focus on one thing at the time. Don't try to change upfront everything. Just too much work. So try to find little things and do it one by one. Use Git or things like this to help you if you begin something and you think you have to go back stash thing in Git and just begin another change that remains small. Whenever you have crashes and you figure out that there is a problem with your design, fix the design first. Don't try to push absolutely your smart pointer at any cost, saying, I have to do that. You need to fix the design and then go back to that. So this may be quite a lot of work, but it pays in the end because your design will be right better. So here is the last slide, if I'm right. This is really better. You should push it. So this eliminates the downlink pointer, enforce your design, make the code self-documented about the passing or not of the ownership. This reduces the mental load when debugging because it's now clear who owns what. And there's no more misalignment between new deletes and all the stuff. So smart pointer are not only making your code safer now, it will help you keep it safe in the future, and that's the main point.